Okay, so today I'm going to discuss with you the binomial expansion using the binomial theorem. But before we go to the discussion of this topic, may we have first a review of our basic concept about combination. Combination, okay? Combination can be computed by using the formula the combination of n taken r at a time is equal to n factorial over n minus r factorial times r factorial, where n is greater than or equal to r. Okay? So the combination formula is the combination of n taken r at a time is equal to n factorial all over n minus r factorial times r factorial, in which n is greater than or equal to 3. Let's have two examples on this. Find the combination of 5 taken 2 at a time. Okay, so the long method would be 5 factorial over 5 minus 2 factorial times 2 factorial. That is 5 factorial over 3 factorial times 2 factorial equals 5 times 4. Okay, this must be 4 times 3 times 2 times 1 all over 3 times 2 times 1 times 2 times 1. So your 3 times 2 times 1 here is our 3 factorial. And your 2 times 1 there is 2 factorial. So we can cancel out 2 times 1 over 2 times 1, and then 3 over 3, and then 4 divided by 2 is equal to 2. Therefore, 5 times 2 is equal to 10. So the combination of 5 taken 2 at a time is 10. Okay? But when you use the calculator, scientific calculator, I'm using Casio scientific calculator. The factorial or the combination of 5 taken 2 at a time, okay? Just enter in 5 and then press shift and then press the symbol for divide, and then you have there press 2 equals 10. Your symbol for divide is the second function of NCR. You have there the combination of n taken r at a time. Okay, you may try that if you have your calculator on your side. Okay, another example. We have 5 or 10 rather. Combination of 10 taken 3 at a time is equal to 10 factorial over 10 minus 3 factorial times 3 factorial, which is equal to 120. Or we have 5, no, we have 10 shift and then press divide and then press 3 or enter 3 equals 120. So easy, okay? So that is the shortcut way of using computing the combination using calculator, okay? So now we have our binomial theorem. The combination concept is used in the binomial theorem. So we say, let x and y be variables, and n is a positive integer. So the n power of x plus y is equal to the summation of n j, where j starts from 0 to n, of x raised to n minus j times y raised to j. Or in the expanded form, we have the combination of n taken 0 at a time, 0 because the starting value of j is 0, of x raised to n minus 0 is n, times y raised to 0 is 1, plus the combination of n taken 1 at a time, of x raised to n minus 1, times y raised to 1. Take note, our j is already equal to 1, plus n combination of n taken 2 at a time, of x raised to n minus 2, y raised to 2, plus, okay, that would be the same until we get the following terms. The combination of n taken n minus 1 at a time, of x times y raised to n minus 1, plus n, chose n, times x raised to 0, y raised to n. So the final answer would be combination of n taken 0 at a time times x raised to n, plus the combination of n taken 1 at a time, of x raised to n minus 1 times y raised to 1, plus the combination of n taken 2 at a time times x raised to n minus 2 times y squared, plus the combination of n taken n minus 1 at a time times x raised times y raised to n minus 1, plus the combination of n taken n at a time times y raised to n power. So that is the expanded form of our n power of x plus y. Okay, so we can also determine our coefficient here, even if we don't provide all the terms in the given expanded form. Okay, for example, expand x plus y raised to the fifth power. So x plus y raised to the fifth power is equal to the combination of 5 taken 0 at a time times x raised to 5, plus the combination of 5 taken 1 at a time times x raised to 4, y, that is 5 minus 1 is 4, plus the combination of 5 taken 2 at a time times x raised to 3, 5 minus 2 is 3, y is raised to 2, plus the combination of 5 taken 3 at a time of x raised to 2, that is 5 minus 3 is 2, y raised to 3, plus the combination of 5 taken 4 at a time, x raised to 1, why? Because 5 minus 4 is 1, times y raised to 4, plus the combination of 5 taken 5 at a time times x raised to 0 is 1, times y raised to 5. So the final answer is the combination of 5 taken 0 at a time is 1 times x to the 5th is x to the 5th, plus the combination of 5 taken 1 at a time is 5 x to the fourth, 1. Plus the combination of 5 taken 2 at a time is 10, x cubed, y squared. Plus the combination of 5 taken 3 at a time is 10, x squared, y cubed. Plus the combination of 5 taken 4 at a time is 5. You may verify that with your calculator. Times x times y raised to 4. Plus the combination of 5 taken 5 at a time is 1. Times y to the 5th is y to the 5th. So that is the expanded form of the 5th power of x plus y. Okay? The other one is expand x plus y raised to 8. So we have x plus y raised to 8 is equal to the combination of 8 taken 0 at a time, x raised to 8, plus the combination of 8 taken 1 at a time, x raised to 7, y, plus the combination of 8 taken 2 at a time, x raised to 6, y squared, plus the combination of 8 taken 3 at a time is equal of x raised to, what is the exponent of x here? 5. What our exponent of y? 3. Okay? Plus the combination of 8 taken 3 at a time. Sorry. It must be 4. Combination of 8 taken 4 at a time. X raised to 4. Y raised to 4. Plus the combination of 8 taken 5 at a time. X to the 3rd power. Y to the 5th power. Plus the combination of 8 taken 6 at a time. Times x raised to 2. Y raised to 6. Plus the combination of 7, combination of 8 taken 7 at a time, times x raised to 1, y to the 7, plus the combination of 8 taken 8 at a time, times x raised to 8 minus 8 is 0, and x raised to 0 is 1, times y raised to 8. So the final answer, expanded form is combination of 8 taken 0 at a time is 1 times x raised to 8 is x raised to 8. Plus the combination of 8 taken 1 at a time is 8 of x to the 7th y. The combination of 8 taken 2 at a time is 28 of x to the 6th y squared. Plus the combination of 8 taken 3 at a time is 56 times x to the 5th y cubed. Plus the combination of 8 taken 4 at a time is 70 times x to the 4th y to the 4th. Plus the combination of 8 taken 5 at a time is 56 x cubed y to the 5th. Plus the combination of 8 taken 6 at a time is 28 x squared y to the 7 y to the 6 y to the 6. Okay, plus the combination of 8 taken 7 at a time is 8 x y to the 7 plus the combination of 8 taken 8 at a time is 1 times y to the 8 is y to the 8. So that is our expanded form for the 8th power of x plus y. Okay, another example, and this example is all about finding the coefficient of unspecified term. Okay, so let us try this. What is the coefficient of x raised to 8, y raised to 7 in the expansion of x plus y raised to 15. Okay, so we are going to get the numerical coefficient of x of the term whose exponents for x is 8 and y is 7. Okay, so we have, using the combination concept, we have, since our n is 15, we have here our 15 and the value of j is 7. So we have j here. Therefore, we have 15 taken 7 at a time, or 15 factorial over 15 minus 7 factorial times 7 factorial. And that is equal to 15 factorial over 8 factorial times 7 factorial equals 6,435. Okay, so the coefficient of the term x to the 8, y to the 7 in expansion of the 15th power of x plus y is 6,435. Okay, so easy to determine or find its coefficient because we are using the combination or combinatorics concept. Okay, and the other one is, so we have here the coefficient of x raised to 8, y raised to 7 from the expansion of x plus y raised to 15 is 6,435. So its complete term would be 6,435 x to the 8, y to the 7. But this is our final answer. Okay? So next problem, we have example number 4. Example number 4. So what is the coefficient of x to the 5th, y cubed in the expansion of 2x minus 3y raised to 8. Okay, so we have our solution again. We have the summation of, okay, so we have 8, 3 there, 8, 3. The combination of 8, 3 are taken 3 at a time times 2x to the 5th times negative 3y raised to 3. And that is 56. Combination of 8 taken 3 at a time is 56. And then you have 2 to the 5th x to the fifth times negative 3 to the third power times y to the third power is equal to 56 times 2 to the fifth is 32, x to the fifth, and negative 3 raised to 3 is negative 27 times y cubed. Okay? And multiplying all of those, we have negative 483 or 48,384. So the coefficient of x to the fifth y cubed in the expansion of 2x minus 3y raised to 8 is negative 48,384. Okay, so that's how we can make use of the binomial theorem, finding the expanding a binomial expression raised to n power and finding the coefficient of a certain term in a given expansion of a binomial expression. Okay, thank you.